This is the third lesson in our geometry unit. It's called Angle Measurement Pairs Plus, and we're going to be doing some protractor work. So the warm-up, the angle's already lined up on the protractor, which makes it a little bit easier. And it says angle AVB is circle 1, acute, obtuse, right, or straight. And I went straight into this without telling the kids how to name angles, because for the most part kids usually remember how from elementary school. But we are going to go over naming angles just to make sure that everybody remembers how to do it properly. So angle AVB is an acute angle, which means it has to be less than 90 degrees. If I look at the scale, I can either do, well, it starts at 0 to go 0, 10, 20, 30, 40, that's about 48. Or I could have just said, well, this line goes through right here, which is either 48 or 132, and the acute measurement is 48. BVC. BVC is an obtuse angle more than 90 degrees. So, again, I can either start at 0 and go up, or I can say, well, it's either 48 or 132, and 132 is the obtuse measurement. And AVC, well, that's a straight angle. Makes a straight line, and all straight angles are 180 degrees. And it's interesting to see how many kids notice that, well, we use both measurements, 48 and 132, from here, because the line didn't change. It's just which side of the line we're looking at that changed. So, okay, so today's objectives are to review angle naming conventions and vocabulary, and to practice using a protractor to measure angles and identify patterns that we find when we make those measurements. And then here's your homework update and the agenda. Alright, so angle naming. The same angle is shown here twice, but on the second one I added a line segment that turns it into kind of this triangle with rays going off to either side. And I asked the students to name me a point, and to name me a ray and a line segment, 2 ways to name an angle, a triangle, and then another angle. And a point is generally pretty easy. There's point B here, there's point U, there's point G. I'm going to go with point B for fun. Number 2 says find a ray. Well, a ray is a line that starts at one point and continues off forever in another direction. So since it starts at U, I'm going to start with U. And I could do toward G or toward B. In this case, I'm going to do toward B. So this is ray UB, and since it's going from U toward B, I'm going to put this little arrow on it. A line segment is a line that ends on both. It's a segment of a line, as in a piece that we took out of a line. A line goes on forever, but a line segment stops. It has endpoints on both sides, and the only line segment here is BG. I mean, technically you could say BU is a line segment if you are only looking at the portion that's between B and U, but it does continue off in a ray. BG actually stops. There's no ray continuing on. So our line segment here is BG. Put a little line segment over it. Alright, so for an angle, easiest angle is obviously angle U, because you can see it here, you can see it here. Angle U is the only one that's present in both figures. I can just name it angle U because that's the only angle with a vertex of U. So if I say angle U, you know which one I'm talking about. But another way to name it, to be more specific, is that it's angle BUG or angle GUB. BUG, GUB. Angle BUG. And it's very important that the U stay in the middle. The vertex is always the middle letter in a name for an angle. Triangle. Well, there's triangle BUG. triangle BUG. So it's an angle when we put the angle sign in front, but it's a triangle when we put the triangle sign in front. And I could have started anywhere. I could have said triangle UGB or triangle GBU. It doesn't matter. And another angle, I see angle B here. Now, because I'm saying B is the vertex of my angle, I can either say angle GBU or angle UBG. I'm going to go with angle GBU. The B has to be in the middle because it's the vertex. This is just some reminders of how to name angles for any students who may have forgotten. Okay, in the figures here, we're going to name all of the angles. I'm going to start with angle A and E. Then there's angle A and L. I like to do this systematically so I don't forget any. So I'm going to do all of the angles that have A in them. A and I. Okay, so I've got that one and that one and that one. So that's it for A. Now I'm going to move to L, angle L and I. And I also have angle L and E. And we already did L and A, just backwards, so we're going to leave that one alone. And the last one here is angle I and E. And I ask, what do all of these have in common? I mean, obviously they're all angles, but what do the names of these angles all have in common? It doesn't usually take very long for a student to say, well, they all have N in the middle, which means that they all have N as a vertex. This angle goes much faster. We have angle FAT here. We have angle TAR. And then we also have the bigger angle FAR. All right, now we're going to actually use what we've learned about, or what we've reviewed about naming angles in order to measure some angles. And I always remind the students of the steps. Extend the line if you need to. If it's not long enough for you to see what's going on, you're going to need to extend that line. Then you're going to line up your protractor. Line up the 0 point first. Whew, it's hard to line up. Make sure the zero edge is lined up, which it happens to be because this one is actually a straight horizontal line. Oh, this does not want to line up properly. There, that's as good as I'm going to get it. Alright, and then I'm going to say, well, what is angle RAP? That's angle RAP. Well, that's 90 degrees. What about angle CAP? 90 degrees. That one's easy because it's 90 degrees on the inner and the outer scale. Angle CAR, well, that's 180 degrees. Is it a coincidence that the two 90-degree angles together make a 180-degree angle? Of course not. 90 and 90 makes 180. Alright, this is our next one. I'm going to go ahead and extend my lines because I have a feeling I'm going to need to. I'm just going to extend all of them just to make life a little easier. And I'm trying to extend them as carefully as possible because I can accidentally change the measurement of an angle by extending a line wrong. Like this one isn't quite on there, I feel like. That's more like it. And then this one here. Surprisingly difficult to do on the computer. Alright, so next I want to line up my 0 point. Whoa, I didn't need two of them. Didn't know I could even have two of them. Angle OVL, I'm going to start with the first one, OVL. OVL. So I'm going to go ahead and line up my 0 point with my vertex. And these all have the same vertex, so that's not really going to change. I also need to line up my 0 edge with one of the sides of the angle, so I can either line it up with the OV side or the VL side. This one requires less movement, so I'm going to line it up with this one. Alright, so I have my 0 edge lined up. Now I can find the measurement of the angle. Again, either start at 0 and go up, or just go, well, this is between 60 and 70, and it looks like it's 68, 69. I'm going to go with 69. 69 degrees. 10, 20, 30, 40, 50, 60. 1, 2, 3, 4, 5, 6, 7, 8. It's between 8 and 9. I like to round up. Angle OVE. OVE. So I need to line up. It is lined up on the 0 edge, but that's not helpful right now because the other side of the angle is not even on the protractor. So I'm going to rotate this back down. There. Now I can measure this angle. Looks like it's on about 21. And then LVE, I don't even have to move the protractor because it's already, VE is one of the legs, and LV is one of the legs, and it's a 90-degree angle. But I didn't even need to measure that because the box tells me that this should be 90 degrees. As long as it's drawn to scale, that should be correct. Alright, this one here. Let's measure this one too. Extend the lines. Oh Lord, this is interesting to try and line up. Okay. Oof. Alright, move my protractor. I want SOL first. So line up the 0 point. Line up SOL. I need to line up one of those legs. So I'm going to go with this one. And it's an acute angle, and it's going through at about 48. Okay, SOT. Line up OT. Line that up. That looks like it's going through about 42 or 43. And angle LOT is a 90-degree angle. Alright, I'm probably not going to measure the rest. I'm just going to put what their measurements are. So we have 90, 90, and 180, and when you add those, they make 180. This is what I want kids to start noticing. 69 and 29, when you add them, make 90. And 48 and 42, when you add them, make 90. And then over here, this one, actually I do need to measure it. I'm pretty sure it ended up being like 125 and 55. Pretty sure. Need to extend my line some. Get on there. Get my protractor back out. Line up my 0 point. It goes through at 55. Yeah, 55. Good. It's 55 and 125. And I actually don't need to measure any of the others. If I know that this is 55. I know that this is 125, and then this is 55, and then this is 125. And the kids actually measure this. TOY is 180, but we're trying to learn why that happens. That's why I want kids to pick up on the patterns themselves. So I just ask for, what sort of a pattern do you see when you make the measurements? And they'll say, oh, well, they were the same. 180, 180, 125, 125, 55, 55. And over here, I'm going to go ahead and skip this one, but we get the bulk of what we need to understand from these here. We made 180, which was a straight line. When we added these two angles, we made it 90 degrees. When we add these two angles, we make 90 degrees. When we add these two angles, we make 180 degrees. 55 plus 125 is 180. So these are the patterns you start to see where smaller angles add up to make the bigger angles. And then the kids just have some more practice. And I believe this practice is just for measuring. Yeah, actually physically measuring. And the homework is just a protractor, find the measurement of all the angles. The trick here is that, like, CAB is easy. CAB is 59 degrees because it's acute, and it goes to 1 before 60. Let's see. EAF is easy. It's 11 degrees. Whoa, no, 6 degrees, because that's the 10. 6 degrees. EAF is 6 degrees. That's easy. DAF is easy because DAF, it starts at 0, goes up to 66. Really, anything ending in F or ending in F or B is easy. F or B. CAF. It's obtuse, so it's going to be 121. EAB is 174. And DAB is 104, because it's obtuse, 114. Obtuse between 110 and 120, 114. The challenge would be, didn't actually ask for it, but what would angle CAD be? Angle CAD, for example. Because it's not lined up with the 0 edge, so you can't just look at where the angles fall. You have to actually either count, or you can start to figure out what each angle is, because you know that all of them have to make this straight angle. They have to make 180. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, not quite 55, so 54, 5. And you also can see that DAF is 66 and EAF is 6, so they're a difference of 60. This should be about a 60-degree angle. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 4, and another 1 makes 60. Just starting to notice some patterns when measuring angles to prepare us for our next lesson, which is going to be on angle relationships.